Hi everybody. In this video we're going to learn how to query an SQL database, or specifically how to query a single table in a database. Later we'll learn how to write queries that'll span multiple tables, but for now we'll stick with one table. We've already seen one query. We've been writing this one, select splat from and some table name like books. And if our books table was 20 columns by 100,000 entries, that's what we'd get back. We'd get back that entire table, the contents, all the data of that entire table with this query. And most of the time, like 99.99% of the time, that's not what we want. We want to get some specific information back, like what books did a certain author write, or give me all the information about this book, or which of our customers live in Dallas, Texas, things along those lines. So we want to write a very selective select statement, and that's what this video is about. Before we can do that, we need some data, some database to work with. And these are the two databases we'll use, tomato.sql and world.sql. You can get these files at that website that I list there. Let me just give you a really quick, for those of you who don't know how to download this stuff, just a quick little update, a 2-minute diversion into doing that. And let's see if I can do it in 2 minutes. So here's that course. If you go to it, or that web page, if you go to it, there's 2 ways to download, or there's probably more than 2 ways to download. But one way is, if you're here, the information we want in this directory SQL files, and there may be more here, but the ones we're interested in are in this tomato and world SQL. If you click on that, that's all the data in that file, but you need to click on raw. And once you get that, you can download that web page just how you normally download the web page. On the Mac, it's Control-click, and you'll get that Save As menu where you can save the data or save that file. Let me just go back again. And if I wanted World, I would do the same thing. Click on World. Click on Raw. And then do that Save As. Another way is to click on this clone or download, and that'll download all the files you'll need for this course. So either you can select the download the zip, or if you want to use Git, this is the address to use. You can just copy to the clipboard by clicking here, which I'll do here. Now that address is in my clipboard, so I can just merely go to my terminal. Let me just clear here and type git clone that information. And now you can see that that course is there. I can just change into it, or that those files are there. There's that SQL file. Let me just change directory into that. You can see that there's the tomato SQL file and the world SQL file. Those are the ones I need to save or insert into my Postgres server. So let's go ahead and do that. Okay, so I'm going to insert the tomato SQL file, and then I'll insert the world one. That's a little bit longer, and then I'm done. So let me just quit out of that. So we've done the preliminaries. Now we're ready to start learning about how to write good select statements. Here's the basic query pattern we'll be using for today, or in this video. It's select and then some argument columns, which we'll look at shortly, from a particular table. And then this next part in red is optional, where some condition holds. Well, it's optional in that you can have it without, but most of the time you'll be having some sort of where clause in your query. And that stuff that's after the where, that condition, is something that's going to evaluate to be true or false, where author equals Ann Mulkern, or something along those lines. So where some column name equals some value. So that's what we're going to be writing. So let's give it a shot. So here I am in my terminal. I'm going to log into Postgres. And now I'm going to change into that tomato database. And let's take a look at what tables are in the database. There's an actors table, a single table, and let's take a look at the structure of that table. So we have an ID, which is the primary key, as we can see down here. We have the last name and first name of an actor. We have the role that actor played, the name of the movie, the tomato rating, so what was the score on Rotten Tomatoes, in minutes, what's the runtime, and what year was it released. So that's the information we have there. And let's say we're interested in the movie Iron Man 2. So let's get the information on Iron Man 2. That's the new where that we're learning. And the movie equals and there we get the information from about Iron Man 2 when we see the actors that were in it. And let's say we're interested in the movies released in 2010. So it's the same thing. So we select splat from actors. And here you see I try to stay capitalization on the keywords, but remember things are case insensitive. And here we get all the actors and what movies they were in from that matched 2010. Let's switch over to the world database. Let's take a look at those tables. So we have a city table, a country table, and a country language table. Let's take a look at the city table. So we have an ID for the city, the name of the city, what country it was in. So countries are things, 3-letter codes like USA for the United States of America, CAN for Canada, FRA for France, and so on. The district of that city, so in the United States, it's the states. In Canada, it's the provinces, and so on. And the simpler one, the population of that city. And suppose we're interested in cities, all the information about cities that are over 8 million people. So let's see how we can do that. Select splat from city, and we introduce the where, and we want population greater than 8 million people. And there we have it. So there are 10 cities when this database was created that are over 8 million people. So the comparison operators we've seen are the equals for that one with what movies are released in 2010. The greater than we just use now. As you can imagine, there's less than equals, greater than equals, and not equals. So those are the operators available to us. So we've covered this where, and as you can see so far, it looks fairly straightforward. Now I'd like to direct our attention to this columns. So far we've been using this asterisk here for columns. Select asterisk from whatever table, and that simply means all the columns. If we want specific columns, we just list them between the select and the from. So let's go ahead and look what that looks like. Let me change back to tomatoes. And let's say we're interested in the titles of the movies that were over 2 hours long. And again, let's just take a look at the structure of that. So we have the runtime and then the movie name. So we want the titles of the movies that are over 2 hours long. So the pattern is select, and now we specify what columns we want. Well, we just want the movie column. So this is in minutes, so 120 minutes. I misspelled actor. The table is called actors. And there we get them. So we get entries for Iron Man 2, Avengers, Captain America, and so on. Now you may wonder, well, why are we getting these repeats? Why are we getting 4 Iron Man 2s? And let me explain that. Go to our tomato database. This is in just an editor, and here's information from Iron Man 2, and you see we have multiple rows where the title of the movie matches Iron Man 2 because we have multiple actors. So each row consists of an actor, a role, and the movie they're in. So we're going to get multiple entries for Iron Man 2, which is why we see them here. So we're getting results that have multiple occurrences. As you see at the way bottom of the screen on the left, we have a colon there, and that just represents that this query returned more rows than what I'm showing you in the terminal. To see the remaining ones, I just hit space, and that just shows more of the entries. I can hit either Q here to quit, or just keep hitting space to see more. And now when it ends, to get back to the query or the prompt, I just hit Q here. So let me just up arrow to get that again. Now it's showing that I have more. I can just hit Q here and it returns with the prompt. Let's say that's not what I want. I actually don't want multiple entries for each movie, but I only want the unique names. So I only want one occurrence of Captain America, the First Avenger. How would I do that? That's pretty simple. Let me show you that. There's this word distinct, which we can add like this. Select distinct, and then we have the list of columns from actors where runtime is greater than 120. So if on the left here is what we started with, 2 occurrences of Iron Man 2, 2 of Captain Marvel, and so on. After we apply the distinct command, it only shows 1 occurrence of each unique entry. That's exactly what we want. Let's take a look at how that works. So let me up arrow here to get that. So what I want is, in front of movie, I want to put the word distinct. And now we get just 1 entry per movie. Sweet. We'll return to this distinct shortly. Let's say I'm interested in all the movies released in 2010. Select movie, because that's the name of the column I want. And then we have year equals 2010. Ooh, I again have repeats. So by now you know there's a simple way of getting rid of those repeats. It's to use that word distinct. And now we get that there were 5 movies released in 2010, or at least in our very tiny little database. Suppose I want to know what are all the actors' names that are in our database. Let's see if we can find that. So here we can go select first name, last name from actors. Where? Well, it turns out we don't need a where, right? We want all the actors. Select first name, last name from actors, and here's where we're getting those repeats, and we don't want those repeats, right? We wanted just the actors that are in our database. So again, we put that word distinct in front of it. Again, things are case insensitive. I could have done a lowercase distinct or some really wonky distinct like. And I'll get the same results. So here are the unique actors that are in my database. Let me zoom down. There's 94 of them. Let me just give you a little bit more information about distinct. Here's what we were doing. Select distinct first name, last name from actors. And on the left, you can see we have multiple occurrences of the first name Katie. And we still have multiple occurrences of the first name Katie on the right after applying distinct. Distinct applies to the entire row that is returned. So it's not just distinct first name. In this case, it's distinct first name and last name. If I had select distinct first name, last name role, it would be a distinct of all 3 of those. So if Katie Holmes played multiple roles, you'll see multiple occurrences after applying distinct. So remember that distinct applies to the whole row, not just to a single column in what's returned. So distinct first name, last name means a distinctive pair, first name and last name. So I just wanted to make that clear. All right. So we've covered the basic condition, where a condition is some column name equals some value, which can be true or false. We can also use kind of logical ands and ors. So a condition can be like where year equals 2010 and movie equals Iron Man. That doesn't make sense, really. Or we could say where movie equals Iron Man 2 or movie equals Iron Man. So we can have this and an or. Let me just give you an example rather than blather along here. Let's say I want to know all the movies that Brie Larson was in. So select movie from actors where, and here's where I'm going to combine stuff. So the first name equals Brie, and whoops, what am I doing? And right, select movie from actors where first name equals Bree and last name equals Larson. And there we get them back. What about all movies that are under 2 hours and have a tomato rating greater than 90? So all movies under 2 hours with a tomato rating over 90. I'll just stick with lowercase, select movie from actors where. All right, so we want the movie to be under 2 hours. So that's runtime less than 2 hours. And the T rating greater than 90. There we get those back. So we see repeats. How we get rid of those repeats? I'm just zipping along here. We put the word distinct in front of it. And there we get. These are the movies that are under 120 minutes long and have a tomato rating of over 90. What about actors that either played the role of Ancient One or Supreme Intelligence? Those seem like important roles. Let's see who played them. So I want to do select, first name, last name from actors where. So I wanted to know who played where role equals Supreme Intelligence or role equals Ancient One. Select first name, last name from actors where role equals Supreme Intelligence or role equals Ancient One. So there were 3. Sweet. Okay, let's move to the world database. What about all cities and state names of cities in Colorado and New Mexico? So let's take a look at that city table again, just to refresh our memory. So remember, the state names were in this column, district. So let's see if we can do this. So we want the cities. So that's the name and the district. So now I'm interested in cities in Colorado or New Mexico. So that would be district equals or and there I get them. Sweet. Okay, now here's a hard one. Let's see if we can find the cities in Norway, which is the code NOR, or Sweden, SWE, whose population is over 200,000 people. So the city has to be in Norway or Sweden, and also the population has to be over 200,000 people. So let's see if we can do this. So if you think you know how to do it, why don't you stop the video and give it a shot. But here I go. And let's say I'm interested in the city name, the country code, so Sweden or Norway, and then the population of that city, just so you have a sanity check here. So it's the name. Okay, and the country code can be Norway or can be Sweden, and population, we want greater than 200,000 people. So there we get it. So these are cities in Norway or Sweden whose population is over 200,000 people. And notice that I use these parentheses here. And let me just play a little bit with those parentheses to show you the importance of them. So if you're familiar with any programming language, this isn't new to you, and it's just a reminder to be careful. So I'm going to move these parentheses, as you'll see. See, whoops, I need to get rid of one parentheses here, sorry. All right, so this is a slightly different syntax. Why don't we go ahead and take a look at it, where the country code is Norway, and here I have the parentheses, or the country code is Sweden and the population is over 200,000. And you can see I get a different result here. So I get every city in Norway and just the cities in Sweden that are over 200,000. So these parentheses are sort of important. Let's look at another pattern. It seems like we're sort of mastering this one, or at least I hope we are. Suppose I'm interested in all the cities' names that start with the word new. So right now we don't have kind of a way of doing that. The next thing is, well, how do we do that? And we use this like pattern. And how like works is this pattern contains some sort of string that has like an I don't care or wildcard character in it. So where some column name is like matches a specific pattern. And the patterns are that this % is the wildcard character. So if you have a letter A followed by the wildcard, that matches any string that starts with uppercase A. If we have the wildcard first, so that can match 0 or more characters, and then it ends with ED, that matches any string that ends with ED. If we have this occurrence, the third line here, so we have capital A %ED, so that matches any string that starts with the capital A and ends with ED. And finally, this one with the %Z%, that matches any string that contains a Z. It can start with a Z because this % matches 0 or more characters, so it could be no characters. It could end with a Z, again for the same reason. This last % can be matched nothing, or it can have a Z in the middle. So it should match that. So let's give that a shot. So let's say we're interested in cities that start with the word new. So we would do select. Let's just say I'm interested in the name of the city. And now the pattern is we give it a column name. In this case, it's the name of the city we're interested in. That word like. And then the pattern we're interested in matching. It starts with the word new. Whoop, and I forgot the wildcard character. So we get 12 cities that start with the word new, or the letters NEW. So if I didn't have that, that's just matching the literal string new. Are there any cities that consist of solely the word new? There are none. What happens if I was interested in cities that have the word city at the end, like something city? That would be, it can start with anything, and then I want it to end with the word, city. So it starts with anything. I have a space here, ends with city, and let's give it a shot. So there's all the cities, all the names of the cities that end with the word city. This is useful if we have a dynamic search bar on a website we're developing. So let me just kind of give you that example. So here, let's say we're typing something in like N, and as we're typing in letters, we see results dynamically appear. This kind of works in a lot of places, like we're typing in Google or other sites, that as soon as we start typing, we're seeing results. So we type in N and we might get these displayed. We add another letter, NE, and that shows another set of returned results. And finally we type new and we get those in. So as we're typing, we're getting more and more refined search, and we can use like in this case. So that's like. Suppose I'm interested in, I don't care about case, whether it's a capital N new or lowercase new. I just want to know if it has new. In that case, we use, backing up here, this I like pattern. So I like means insensitive, case insensitive like. So I don't care about whether it's upper or lowercase. Does it just match the pattern? So let's see how that works. And for that, let me switch back to the tomato database, and let's say I want to know, because I'm a really big fan of the letter Z, what actors have a Z in their first names. So let's see if we can do that. Select, and let's say I want the first names and last names. Okay, and here's where I'm going to use that I like or insensitive like. I don't care if it's a capital Z or a lowercase z, just let me know if it has a Z in it. So in this case, it's going to be first name, I like, and it needs to have a Z in it, so I'm just going to put, there's a Z in it somewhere. And there we get all the results of actors that have the letter Z in it. So now we've covered these kind of inexact pattern matching sort of queries using like and I like. We can't use equal here, so let me back up a bit. We're first name. We get 0 rows back. This is kind of the literal, find me a first name that has a % sign followed by a Z followed by another % sign, right? So we need the like and I like. Let's say I'm interested in any movie with the word Avenger in the title. How do we do that? Let's say I'm interested in just the movie name. Remember, we can't use equal because we just want Avenger somewhere in the title. So let's just go with I like. It has to be the word Avenger somewhere. Right? So Avenger has to appear somewhere in the string of the movie title. Let's see if that works. And we get a whole slew of them, but let's say I just want to know the unique names. So for that, I zoom here. It's something we learned earlier on in this video, and I put the word distinct. And there we get. So there's 5 movies that have the word Avengers in the title. One final thing before the end of the video, and that is to see whether a column is null or not. Does it have any information in that? Does that row have any information in that column, or does it not have information? So let's go ahead and see how that would work. So let's say I'm interested in knowing movies that haven't been released yet. And for that, this is kind of dodgy because there might be some entries that are not there that people don't know when it was released. But for now, let me do the check of whether a movie has been released or not. So let's select movie from actors where year, that's when it was released. And now we want to make sure, is there some data there? So you think, well, maybe we can go something like this. And we don't get anything. That equal doesn't work with evaluating null. You can't compare something that doesn't have any information in it to something else that doesn't have any information in it. That equals doesn't sort of make sense. You can say, is it empty? And that just is null. So we get just one movie in our database, just Justice League Part 2, that hasn't been released yet, doesn't have a date in yet. Movies that don't have a tomato rating, same thing, where T rating is null. So we have a bunch that haven't been reviewed yet. Some of these are coming out, like Charlie's Angels has a release date but doesn't have a tomato rating. Same thing with Wonder Woman 1984. So again, to see those distinct, we would put the word distinct in front of it. So let's say I'm interested in the reverse. I want to search for something that doesn't have a blank in a certain column. For that, we use is not null. So let's see an example of that. So let's say I'm interested in all the movies with Gal Gadot that have been released, so have a year. So I would do this. Select, I want the name of the movie from actors where, so first name, and year is not null. So that is not null means there has to be an entry in that year column. So I get 3, Wonder Woman 1984, and Ralph Breaks the Internet. If I don't have that entry, right, I get this Justice League Part 2, which we saw didn't have a release date. So that's the null and is not null. So to wrap things up, we've learned all these basic query patterns. We've learned that we can have distinct in front of stuff to get unique entries. We learned that there's this optional where clause. We've learned what the conditions are So it can just be a simple one, like some column has to have some value. It can have an and or an or to combine conditions, and we can combine even ands and ors there. We have these, does a column match a specific pattern using like and a case insensitive like. And finally, we can see, are there values in a column or not? So we can check if that column is null or is not null, knowing that we can't use equals null because that doesn't match anything, as this slide shows. So if we have unicorn store that doesn't have a length, and if we said where select title from movie where length equals null, it doesn't return anything. It won't return unicorn store. Null never matches null with an equals. When we say select title from movies where length is null, we do get that unicorn store return. So just remember that equals doesn't work with null. So now it's your turn. You can generate queries on your own. That's really the way to do it, just to kind of get this information in your head. It might look easy, but the only way to really learn it and become fluent and quick about things is to practice. You can invent queries on your own, but here are a few to get you started. So what movies was Anne Hathaway in? What year was the movie's Hackers released? On to some more complex ones that involve you using distinct and ands and ors. So I hope this video was helpful. Thanks for watching. See you next time when we cover just a few more kind of amendments or additions we can use. Not really much more complex things, but still looking at what we can do with single tables. Thanks so much. Bye.